Thank you very much, dear friend, Professor Mohammed Azami Idrisi from FAS. And now we will move to examiners. And the first examiner with us is Professor Hassan Bilyamani.
He's not connected, but we can go to Professor.
Okay. So we'll give immediately the floor to Professor Muna Mudghiri from the Faculty of Medicine and Pharmacy of Rabat from Mohammed V University. You have the floor.
Thank you, Mr. Chairman. So I'm really glad to be a member of your committee members. I congratulate you, مريم, for your work, for your thesis and presentation. So I will be speaking in English and switching to French if I don't find words to explain what I want to say. So please excuse my, I will be jumping from French to English. So first of all, I would like to congratulate you for the choice of the topic. It's really interesting. And it's a pandemic that's still here. So everything is important and maybe need to be updated. So we will have a good topic. I think I will be uncomfortable with saying some remarks related to form, or I will give you the manuscript, then you can change and correct some mistakes. That's it. So I will start with some remarks and maybe some questions. For the list of abbreviations, I think it should be completed. Not all abbreviations are abbreviated. Yes, here, for example, in page 5, you should give some more details related to figure 1.2, which consistent use it to see this shapes. I think sometimes when you are given some figures, when you are listing some figures, it should be figure A before B. So you can switch A and B, but A must come before B. Yes, for the aims of your work, the aim of your thesis, I appreciate the list of aims you cited. But I think you can give a workflow of genomic analysis for each genomic analysis you have performed, just to show how you can do this work in general. So it can be one of your aims. Yes, for your introduction and bibliography, I think that it should be something talking about genomics. You have used genomics as a tool for pandemic, for outbreaks and surveillance investigations. So you can give some basics information about genomics and maybe some tools that are used and the benefits of using genomics in this field. For your work on TB, I think that it should be mentioned which year the samples were collected and analyzed, because this will give us an idea about if it's still adequate today to use this results, or were there any changes over time? Yes. Also, I have a remark concerning techniques of next generation sequencing that was used to perform the whole work presented in your thesis. see that you have used 3 NGS techniques in the MENA, Morocco, and iron tolerance. I think that it would be useful if you can say why you have used this technique for this. Maybe it's more reliable or more efficient, or maybe during COVID, because we lived this, during this period, we had some problems to have products specific to one technique, so we use it, for example, mean iron or other techniques. So the choice, I think, should be justified, even if it's not a scientific choice. It's not scientific-based choice. So I think here I will say this remark in French because it's more easy for me. I don't want to look for words. So
go ahead.
Okay, thank you. Alors pour proposer le séquençage complet des génomes comme outil de suivi des épidémies ou bien des pandémies, je pense que c'est très très lourd. Même si on parle par la suite, on parle que le coût il est comparable à certains tests qu'on utilise pour différencier entre certaines souches. Mais on oublie que l'acquisition du matériel c'est très très cher. L'acquisition du matériel c'est très important. Ça nécessite de l'entretien, le consommable et à chaque fois la mise à niveau. Donc je pense qu'il ne faut pas comparer ou bien dire facilement que NGS permettra un suivi ou bien utiliser surtout NGS comme outil de diagnostic, mais peut-être proposer que quand on a une épidémie ou une pandémie, après, chaque fois qu'on a un problème de traitement dans une région, préparer un nom de souche qu'on va passer au séquençage. Et par la suite, on va sortir des mutations. En utilisant la modélisation moléculaire, on pourra voir l'impact de ces mutations et là, on pourra dire le problème vient de là ou là, cette mutation confère une certaine résistance à un certain traitement. Mais je pense que le fait de proposer NGS tout simplement pour un suivi, pour un diagnostic routinier, je pense que pour le système de santé, c'est un investissement qui est très très lourd. Donc c'est un point de vue que je partage avec vous. Non, mais voilà. I will move to chapter 6 for your conclusions. So here it's really important for data centralization. Yeah, it's really important to share this information of location and date of collections because we faced this problem during COVID. You have sequences of genomes, but you don't have any idea in which time this was isolated and from which region. So if it's a variant of concern, you cannot track it, and you can do anything with. So it's really important to share, to make correlation sometimes between severity of infection and clinical or epidemiological parameters. Yeah, it's really a good remark. And here, you say with the installation of genomics in Morocco, I think that you are at mid-biotech lab since you say 6 years ago, okay. So, and it's, I think it's a reference in genomics in Morocco. So, with the installations, now you should give directly the name of the structure that have the human resources with required skills that should be a reference in genomics. So, genomic is here in Morocco, and everyone say which laboratory is really doing good job in genomics. So you can see it directly. As for your appendix, chapter 6, you have some small I don't know what are these. Are these version of softwares that were used for the analysis or?
Yes.
Okay. So I will be back to your part when you say that you related what you were doing during 6 years. I think that during these 6 years you were learning how to collaborate, how to work, how to analyze, how to discuss. So you should be optimistic, because when we are suffering, you were not suffering during 6 years, but you were learning. And why to be optimistic? Because now you are defending your thesis. So you achieved your goal, and you achieved your, can I say you achieved your dream?
Why not?
Yes. So it's not really 6 years of suffering, it's 6 years of learning how to collaborate, how to analyze, how to negotiate. So it's really good, because there are other people that will not learn even if they will live 80 years old. So they can't have this chance to learn. During these years you learn a lot. And you should be optimistic, because you are here defending your thesis.
Thank you.
Okay. So yes, just one other remark concerning collaboration over competition. I think competition is also a benefit, but should be rational.
Yes.
So just try always to give the optimistic take of what you have lived, and take the positive result of your experience. That's all I have. And another time I would like to congratulate you for your work, and thank you, Mr. Chair.
Thank you very much, Professor Audrey, for these thorough and very precise questions. And I think if Professor Williamini is not with us,
Can go ahead.
I will take the floor. I will give to myself the floor as an examiner.
You are the president.
Yeah, I will take the opportunity, and I will give myself the floor. So, of course, I'm very happy now not to be present, but rather to talk with you, because the project is so important. I really want to discuss with you some point and to see your point of view about many things. First, when I received the manuscript and I saw the title, I thought that it's just, I will do the Mycobacterium tuberculosis genome, and I will do the SARS-CoV. But it's not the same thing here inside what you did. Your title underestimates your work. I think you should put something rather impact of SARS-CoV-2 infection in Morocco, Kama, a region with high Mycobacterium tuberculosis infection rate, something like that. So you would be looking at SARS-CoV-2 infection, but in a region where the rate of infection with Mycobacterium is high, and here it will give a much more valuable input, rather than we feel here that you're just doing genomic here and genomic here. You see what I mean? But inside, when I read it, I was very happy, because I saw that you really gave this interaction, this crosstalk between both of them, and that's very interesting. But we don't feel it here in the title. And you underestimate your work. You should be doing at least a balance. But here you really underestimate. Okay, I suggest that with your advisors, with your supervisors, to search for a title more valuable that really reflects what you've done in the work. So that's the first thing. When you were talking about the mutations that you have found in Mycobacterium tuberculosis, and you talked about the gear A and gear B, and you said that the mutations, the modeling of these mutations, decrease the binding of one of the antibiotics, fluoxacin on the bacteria. And I was just wondering, this is so interesting, but you've done it in silico, right? Is there a possibility to do it in vitro?
Yes.
Are you planning that?
We need the strain, so if I have the strain, yes, I can, but I don't know. Maybe.
I think the best way, the strain, I guess, is dangerous, right?
Yes.
But what I'm thinking about is an incompetent strain, which will keep everything that is happening, which would still bind.
Yes.
I'm sure that should
no,
be
the way we did it is you take a susceptible strain and you mutate the gene and see if this mutation has an impact on the resistance or not.
Yeah, but you're going to manipulate the wild type strain.
Yes, the wild type.
No, what I'm suggesting is whether there are some strains which are,
Not prevalent?
That's good, that's not
Yes.
there.
Okay, I don't know. I don't have.
Yeah, for instance, for SARS-CoV-2, there are
There is
some.
this.
Yeah, there are some strains which are not prevalent, so you can
Maybe.
manipulate in the lab, and in that way you will take the antibiotic and the incompetent strain,
Yes.
and then put them together and see whether you can bind before the
Yes.
fixation, before the mutation, and whether the bind, and that will be really interesting.
Yes.
Because we will join what you've seen in silico with the real experimentation. I think you've answered this question when you talked first about the strains. I was wondering where did you get these strains, but you said Casablanca and Rabat.
The makeup material?
Yeah, I think only Rabat.
TB, it's only Rabat.
Only Rabat.
Yes.
It's
The
SARS-CoV-2,
military
which is
is-
Casablanca
yes,
and
SARS-CoV-2
Rabat.
was okay.
And another point that I liked is when you talked about all the countries where you have, I'm switching here to SARS-CoV-2, right? And countries where you've checked I mean, this is a figure that you've taken from the World Health Organization, the WHO, where you've seen a really low cases in terms of infections, right, in Africa, right?
Yes.
And I'm wondering, because you spent so many years, I mean, 6 years, I guess, or 13.
I've heard it's 30 years. Six for It's more than 13, by the way. So coming back to it.
Okay. And I'm wondering, you have so much experience now. Why do you think Africa was not as, strongly affected as other regions? Is it
With
because of the virus? Yeah.
So I think that
Don't be just a genomic person,
No, I
because
would
there is
be
not only
really-
genomic. Think about immunology also.
So what I think, so in Africa we have other diseases that have emerged, and many studies have done this correlation between vaccines that we use in Africa and the spread of the virus. The BCG vaccine has shown to be, countries with the BCG vaccination regime have low spread of the virus and have low infections. So this could be a reason in Africa, because many countries use the vaccine of BCG, including Morocco. Also, maybe the genetic of the population is different than the rest of other geographic location. So maybe the virus adapted differently to Africa than it did in the rest of the world.
But the first explanation that you gave, meaning BCG, it means that maybe we have an immune system with some T cells, B cells, that recognize SARS-CoV-2 as it will recognize
TB.
TB.
Yes.
This is your hypothesis?
Yes.
Okay. Good. This is exactly what I think as well, but I'm not sure, because we need to do experiments in order to confirm the hypothesis. This is cross-reactivity. This is what we call cross-reactivity. It has been shown, though. It has been shown.
Yes, there have been some studies on the correlation between BCG.
Where they have taken people who have not been infected with SARS-CoV-2, and they have found a percentage of these people with cells and antibodies against SARS-CoV-2. Although they have never seen SARS-CoV-2,
Okay.
they have antibodies and cells against SARS-CoV-2,
Okay. Yeah.
which basically goes with this
Yes.
hypothesis,
Yeah.
right? Maybe we have a higher percentage in Africa compared to other
Yes, for
regions.
this, the TB is very common in Africa compared to Europe or America. So
Well, the only difference between you and I'm thinking about cross-reactivity with other SARS-CoV, like SARS-CoV-1. You're talking about in TB, I'm not sure whether it's
But in Africa, the SARS-CoV-1 was not very predominant.
But not only SARS-CoV-1, I'm talking about coronavirus.
Coronaviruses, maybe. Yeah, it could be. So there's many hypotheses, but you cannot put your finger on which one is
So when you talked about database in Morocco, why not in biomed, in med biotech? Why not in Morocco? Why not in Africa?
Yes, but it's, as I said, it will take a lot of collaborations to do something.
Yeah, but it's much more, I mean, I know that you are in a great club. I mean, I'm not saying it just because Asdin is here. You are in a great club, and the ambition should be big.
Yeah.
And I think you guys have the ability to do that. I mean, to think about a database, an African database, where you will put all this, the sequences.
It is a project. It is a project
of yours.
There is an African project that's coming out, and we actually submitted a paper for science that hopefully will come out, saying that including all the GSED variants, that are African variants in GSED, that were analyzed to come up with the phylogenetics. So there is a very nice project. I don't know if it's going to go through or not, but there is an African project in this sense.
Great. Yeah, I think that's, I have, so this is a question that have been, I think, discussed with Professor Sperbu, but I'm going to, I'm very interested by the universal vaccine.
Mm-hmm.
But when Professor Sperbu asked you the question about universal vaccine in Morocco, you said there is no mutation in the spike protein. Therefore, I think that universal vaccine would work in Moroccan population.
It's not just the spike protein, but it's in general the mutation that we found in Morocco are not any different from mutation that we found elsewhere. So this is just.
Therefore, you think that universal vaccine will work?
So it is less much of an impact of the mutation. This is what the virus are. They mutate, so it's normal. And there's many vaccines that have been working for other viruses, so I don't think there should be a problem. I'm not an expert in immunology, but in my opinion, I guess it should not be a problem. It's not mutating at a certain rate which should be alarming. It's still be normal.
Yeah, but you know, if you take, for instance, the Indian variants,
yeah.
And we take with the Indian variant, for instance, the Oxford and AstraZeneca vaccine is not very efficient for it. The South African variant, AstraZeneca, is not very, of course, it's active against the strong cases. But I'm just surprised that you say that for the Moroccan population it could work because there is not much mutations, but we can just get the bacteria, the virus from abroad. And we will have
no, because the question wasn't about Moroccan, so I have the same idea of the world in general. The number of mutations that the virus is accumulating doesn't scare much. So it's still normal for the virus to have this much mutation.
Yeah, but what I wanted you to do is maybe to try to figure out a way to say, okay, I have been working on this sequence for so long. I found a sequence that has never mutated, and it is important, for instance.
Okay. We have done this with the selective pressure. We have found some sites which are not mutated, which are under positive genetic selection.
And they are important for the virus. And if you
in the spike protein.
In the spike
yes,
protein.
We have found a
so those will be interesting in the universal vaccine. Those will be interesting.
But you remember at the beginning when the concept of the vaccine was coming out, the problem was we're just choosing some sequences that will be reacting and bringing antibodies. But now I think why we are talking about the second generation vaccines, we are talking about more specific epitopes.
Now this is what I want you to do, to say, if you take this region, I have like 95% chance.
It will still the same.
It will stay the same.
Yes.
And that would be interesting. And then give me that sequence and
okay.
Yeah, that's right.
I think I have to stop because it's really interesting.
Yeah.
I enjoyed it. There are a lot of things to talk with you, and I think I will give. Thank you very much. It was very interesting. Your talk was really great. I learned a lot, but I'm not surprised. You are in a great place. So congratulations, and if you want to do a postdoc, come to my lab.